Hello everyone, Namaskar. In this video, we are going to have a look on the Mc-Culloch model, which was the first model, okay, and this model was developed by the Mc-Culloch to mimic the behavior of a neuron, which we discussed in the previous video, because a brain is made up of neuron, which is a fundamental unit, and there are certain elements of that neuron which we have discussed, which were the dendrites and the soma and axon. These three are the fundamental unit parts of that particular neuron, because the dendrite we take input, in the soma the input gets processed, and then through axon we get the output. So here what we have, simply we can see a model here, right, like this. You can see this thing. Okay, this is a simplistic model in which what we have, there is a circle in which we are having two symbols. The first one is this, is called the summation symbol, and second one is this symbol, which is what activation function. So these two are the processes. So these two processes are done in the Mc-Culloch model. And what are these? What happens here? Look. Let's say x1 and x2 are the two inputs. Simple. These two inputs are multiplied by the corresponding weights. Okay. Let's say x1 is multiplied by w1 and x2 by w2, and then these two are going into the funnel and are summed up. Okay. So this summation is something. What it does, it just multiplies the w1 to the x1, w2 to the x2, and simply sum them up. Okay, so we are adding all the inputs multiplied by their corresponding weights, and after the addition what we get? Y in. We get y in. Now remember, very important thing, that this is y we are having at the output, and here we are having y in. This is not y. The y is something we get exactly at the output after activation function. So this y in is a we can say it is an intermediate variable, right, and which we get only after multiplying the input with the weights and adding them. And once we get the y in, then this y in is applied into the activation function. Are you clear with this? Firstly, we are taking the inputs, we are multiplying them, okay, taking the input, multiplying them, and getting a intermediate variable which is y in. This is not the final output. I insist, this is not the final output. The final output is something which we get when we give this y in as the input to the activation function. Okay, and after that, what is the activation function? Activation function simply, it is a type of thresholding. There are various activation functions we can use. The first one we are using in the Mc-Culloch is the thresholding. Thresholding, we know. You may have seen the water dam, right? There are huge reservoirs, right, there. But what happens? Till then the water level is less than a particular point, the gates of the dam are not open. Once it crosses this water level, only then the gates are open and the water flows out. In the same way it works. This thresholding is something with the input y in, which is again, remember, the intermediate variable, is greater than or equal to this theta, which is threshold. We can take any value of the theta we want. When it is greater than theta, then the output is 1, and when this intermediate variable is less than theta, then the output is 0. So simple. It's 1 or 0. So basically what we can say, that for a set of inputs, the outputs we are getting are binary in nature when we are using thresholding. And we can also plot the function for thresholding. Simply look, let's say these are the input and this is the output. Okay, input and output. Say, let's be again getting theta is equal to 2. Okay. So whenever the input is less than theta, then the output is 0, and when the input is more than 2, the output is say 1. Okay, this is how we can give the functioning of the activation function. And these activation functions are of different type, right? You can go through them. Let's say we are having tan H activation function, sigmoid function. Sigmoid functions are most prominently used, okay, because they have certain range. They are used for the mapping. We will go into that detail in further slides and the further presentation. But here, I just want to now correlate the two. Okay, look, we are having the X1 and X2 are the inputs which are dendrites in neural network. Not neural network, in neuron, which is dendrite. This process which is in the soma or the cell body is done by this block, and then output which we get in axon in the neural cell, which is why we are getting here. So basically this is the complete analogy of that biological neuron, the system representation and the mathematical representation. Okay, so basically now we are ready to begin with the mathematical representation of this model. We can apply it and we can do whatever we want further to develop different logics and boolean logics, etc. Okay, so this is very basic, just go through it. The theta can be anything, right? You can change the value of theta the way you want. Activation functions is a different topic as it is, right, in itself. So we'll go through it also, right, further. So okay, so this one is for the day. If you have any doubt, right, that why we have taken W1 and W2 only, we can take the different inputs also, and we can take different values of theta and many more, right? Just think about it in detail, and if you have any doubt, just comment it in the section and let me know. Okay, thank you very much. Thank you for being with me. Namaskar.